Welcome back to Manish Kumar channel. So today we are interested to discuss about more problems on limits. Okay, so let us see one example. So that a limit for the given function fz equal to 2 times of z bar divided by z, where z bar is a complex conjugate. Z is x plus iy. This implies z bar is equal to x minus I y, right? So then we have to show that limit does not exist, right, at the origin. Let us find by letting the point z equal to x comma y approach the origin in any manner, right? But when we approach through real axis, right, through real axis, when z equal to x comma 0, right? So we are going to plug in the function fz equal to 2 times of x minus, since y is 0, so 0 divided by x plus I times of 0. So if you see, x is going to be cancel it out, so we are left with only 2. Okay. Now when we take the other path, like imaginary axis, right, then what it happened? 0 comma y, and then we have to plug it here, and then we are going to receive minus 2. And we have seen in the previous video, if limit exists, then it must be unique, right? So this limit is not unique because we are going to get on two different paths, we are going to get two different limits, right? Therefore, limit does not exist, right? Let us do one more example. Using epsilon delta definition of the limit, show that limit z tends to z naught, a2 z square plus a1 z plus a naught equal to a2 z naught square plus a1 z naught plus a naught, right? Where the coefficient a naught, a1 and a2 are complex constants. So to verify this limit, we have to find a delta, right? Existence of delta is important for given epsilon greater than 0, such that mod of z minus z naught is less than delta and greater than 0, which implies f of your function f of z minus f of z naught, basically, right? This modulus should be less than epsilon. So if I'm assuming this is a function of z, then the right hand side is going to be f z naught, right? After taking limit z tends to z naught, right? So this is less than epsilon. So these two terms, okay? And then you see we are going to solve this term. So now if you see this constant terms are getting cancelled it out, right? And then we are going to collect the coefficient a2. We are going to get z square minus z0 square plus a1 z minus z0. And then after solving this, you see we have opened it using the square formula. And then finally we are going to take it as mod of z minus z naught, and then modulus of a2 z plus z naught plus a1 mod, which is less than epsilon. Okay, because we know mod of ax is equal to mod of a mod of x. So that property we have used here. Now we are restricting z minus z naught is less than 1, right? Which implies this term. Let us calculate the second term, right? So if you see here, again, if I'm going to take this modulus property, then mod of a2, mod of z plus z naught, and plus a1, right? Triangular inequality I have used. Now, which is equal to a2 mod of, I'm going to add z naught and subtract z naught. So now this mod of z minus z naught, 2 z naught, and again this is same. So again, you see, using triangular inequality, I'm going to get a2 mod z1 minus z naught mod plus 2 times of z naught plus a1 mod, which is strictly less than, because we have assumed z minus z naught is strictly less than 1. So this next line will be strictly less than a2, and then I'm replacing by 1. z1 minus z naught mod is replaced by 1 quantity, bigger quantity, and then this is same. So now we are able to choose a delta which will be the minimum of this one, and this is already less than epsilon. So we can say that over epsilon this quantity will come. Okay. So now what I can say, minimum of 1 comma epsilon upon a2 mod 1 plus 2 times of mod z naught plus a1, right? If we choose delta in this manner, then the equation 1 holds. This is the equation 1. If you see, this is the equation 1, which is going to be hold true, right? So we got the delta as minimum of 1 comma this, right? Now if you remember the last video, we were talking about this delta is not unique, right? So delta, existence of delta is not unique. Now we are going to see with this example how delta is not unique, right? So this example 3 will illustrate this point, right? So using epsilon delta of the limit, show that limit z tends to 2 plus 3i x plus I times x plus y square is equal to 2 plus 11i, right? So now we are going to say that given epsilon greater than 0, right? We have to find delta greater than 0, right? Such that mod of x plus I times x plus y square minus 2 plus 11i, right, is less than epsilon. This is the condition, right? And in that case, whenever mod z minus 2 plus 3i is less than delta, right? This is the condition. Now we are talking about this x plus I, x plus y square minus 2 plus 11i, this mod. So now I'm going to adjust some term. So this is x minus 2, right, plus I times x minus 2 and plus I times y square minus 9. I'm adjusting the term, and which is less than or equal to, using triangular inequality, mod of x minus 2, right, plus mod of x minus 2, right, and mod of I is 1. Okay, so and plus your, I'm going to use the square formula. So this is y plus 3 and then y minus 3, okay, which is equal to 2 times of mod of x minus 2 plus y plus 3 and y minus 3, okay. Then this term is going to satisfy less than epsilon, right? If we assume if we assume 2 times of x minus 2 plus y plus 3 and y minus 3, this term is less than epsilon, right? Or I can write 2 times of x minus 2 is less than epsilon by 2 and y plus 3, y minus 3 is less than epsilon by 2. So I'm just dividing this epsilon into two parts so that the total sum will be less than epsilon, right? So this is just a kind of adjustment. Any epsilon will work epsilon by 2. If you are going to break it in two parts, three parts, so epsilon by 3 will be taken. So this is just the adjustment so that the right hand side you will always get less than epsilon type, right? Or else you can say that x minus 2 is less than epsilon by 4, right? Okay. Now determine the condition on y. Now determine the condition on y. So what is the condition on y such that your you see y minus 3 is less than 1, right? And y plus 3 modulus can be written as y minus 3 and then plus 6. And using triangular inequality, y minus 3 and plus modulus of 6 is 6. And y minus 3 is less than 1. So if we are replacing with 1, so this quantity is less than 7, right? You got it. Hence, if you see, if y minus 3 is less than minimum of y minus 3, I'm talking about minimum of. What is the minimum? 1 comma, and if you see 1 comma epsilon by 14. If my y minus 3 is less than minimum of these two. Okay, so what am I going to get it here? It follows that it follows that your y minus 3 and y plus 3 mod is less than epsilon by 2 then. That means epsilon by 14 and into 7, which is giving you epsilon by 2, which we have already assumed before, right? So if you see, so now we can see an appropriate delta, right? Appropriate delta, which is equal to minimum of 1 comma epsilon by 14, right? Right. So the setting, what is the setting? Appropriate delta. Appropriate delta by setting. What is the setting here? X minus 2 is less than epsilon by 2 we have to set, and y minus 3 is less than minimum of 1 comma epsilon by 14, right? Then we get now our delta which which is equal to minimum of 1 comma 14 epsilon by 14, right? So we know since delta is not unique, right? This is our remark actually. So I'm going to do the same problem with another delta, right? That's the very important point here. Okay, so if we proceed, if we proceed as you see modulus of x plus I x plus y square minus 2 plus 11I as like x minus 2 plus I times x minus 2 plus I times y square minus 9. Now I'm writing in some different way. I'm taking the common this, so I'm going to get x minus 2 and then 1 plus I and plus I times y minus 3 y plus 3, right? And then triangular inequality which is less than or equal to your x minus 2 and 1 plus I modulus plus mod y minus 3 and mod y plus 3, right? And this again, this will be equal to root 2 mod x minus 2 plus mod y minus 3 and mod y plus 3, right? Since 1 plus I is equal to modulus of this is equal to root over real square plus complex component square. So this is going to be root 2. Okay. Now, if we assume let root 2 x minus 2 mod is less than 1 minus a epsilon, right? And the second factor y minus 3 mod and y plus 3 mod is less than a epsilon, right? Where a is any quantity greater than 0. Okay. Or else we can say that mod x minus 2 is less than 1 minus a divided by divided by root 2 into epsilon, and y minus 3 mod y plus 3 is less than as usual a epsilon, right? Further restricting this y minus 3 to less than 1, right? We get what we get? We get y plus 3 modulus is strictly less than mod y minus 3 plus 6. As usual, we have added plus 3, subtracted plus 3, and using triangular inequality, right? So, which is less than or equal to, and then you can say that which is strictly less than 7, 1 plus 6, which is equal to 7, right? Because y minus 3 is less than 1. So, hence, if your y minus 3 is less than minimum of 1 comma a epsilon by 7, right? Then the second inequality, the second inequality second inequality satisfied mod y minus 3 mod y plus 3 is less than a epsilon by 7 into 7, right? You got a point or not? So which is equal to a epsilon, right? That we have already assumed less than a epsilon. Okay. Now, if you see 1 minus a epsilon divided by root 2 is equal to a epsilon by 7, right? Which implies after solving this, I'm going to get a as 7 upon 7 plus root 2. Okay. So which means that if we choose delta as minimum of 1 comma epsilon upon 7 plus root 2, right? Then the given inequality satisfied, right? So if we choose delta as minimum of 1 comma epsilon by 7 root 2, then your condition is satisfied. It means that we found two delta. One is the delta 1 comma epsilon upon 7 plus root 2, and another delta we have obtained minimum of 1 comma epsilon upon 14. So you see here, this is a smaller delta, right? A smaller range I can say, and this is bigger range, big delta. You got it my point or not? So it depends upon how delta you are going to effectively choose, but it's more important a smaller delta. If this delta work, then any smaller delta will also work. That is what this is a very important problem. So I hope you have understood how to figure it out delta as minimum as possible to satisfy the condition on limit for every epsilon. And I recommend some more problem for you to solve as an exercise, right? So I humble request all of you to solve at least all such problems. Thank you very much. Thanks a lot.